Okay, we have another question under our rotation section of our rigid motions OST review. We do, you do, where we're highlighting how to tackle OST questions that relate to our transformations category. All right, our question here states, what are the coordinates of B prime if triangle ABC is rotated 180 degrees, but this time not just around the origin, this is around about point A. So let me grab my pen real quick here. Because when it says about point A, we have to create a fake origin. So we're going to use our real rotation rules, but when it says about a fixed point, we have to make a fake point. We need fake points to find real answers. So A, because the points we'll need in order to find our A prime, B prime, C prime, again, we need to take a prep step and make some fake points that we need. We're going to use our fake points, and again, I'm sorry, I'm taking a second to write the word fake. But it's important, again, we need to use these set of 3 points. So our fake A, our A prime, is not going to be where it's located on the graph, which is 1, 2 to the right, down 3. Our fake A point that we need is going to be 0, 0, because we're going to rotate 180 degrees, but we're going to go around that point. It's going to be the fixed point. If you had patty paper, your pencil would go right there on that fake origin point. Again, you are allowed to use patty paper. Ask for patty paper if they did not give you any. But again, I want to show you how to find this answer, the coordinates of B prime, when we rotate 180 degrees around that fixed point A. So again, we know A is going to be our fake origin point. And now in order to find the location for B and C, we need to kind of almost use like a vector notation in my mind. We need to find how far away and in which direction they are located from this fake origin point. So where is our fake B point? Well, we're going to start from here, and we are going to go left. So we're going to go in the negative direction, and let's go ahead and count. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to go left 8, because it's left 8 of our origin, our fake origin point. And from here, we're going to go in what direction? Down. Down how many? 1, 2, 3, 4. Again, down being our negative direction. So again, these are the points we're going to use for step 2. Again, we need to create our fake points. Finally, we need to find our pre-image, our fake point for C. Again, our fake points are from where A is located, our fake origin point. So to get from C, from here, we need to go left. So left is negative. It's a negative direction. And how many? Let's go ahead and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then we're right there. So we've traveled left 10 and then 0. We are going to use these 3 fake points, and we're going to use them to rotate 180 degrees around our fake origin point. So when it comes to rotating 180 degrees, again, we're going back to our rotation notes on page 34. Remember, counterclockwise or clockwise, again, we have 2 questions when it comes to how to rotate. The first question is, do we swap X and Y? If we were turning clockwise to the right, like a clock, yes, we swap X and Y. No, we don't. Yes, we swap X and Y. No, we don't. The second question is, which direction or which side, which point do we swap or flip directions? If we're pointing to the right, we switch or change direction of our right number. If we're pointing down for 180 degrees, we're going to change direction. We're going to switch signs for both. So if they were a positive number, we switch direction into negative. If we're pointing to the left side of our screen, again, when we're looking at our rotation rules, we will change or swap the direction of the left number. So it says here we're going to rotate 180 degrees, which means it doesn't matter if we're turning clockwise, like a clock, or counterclockwise. Either way, we're going to be pointing down, which means no, we leave our points in the same spot. We would write X and Y in the same spot as they were, but we're going to switch the direction for both. So since A is 0, 0, and it's staying, we're going to consider that also to be at the same spot. So leaving them in the same position, 0, 0, and changing direction, again, would stay 0, 0. B, and we're going to see all of this in print soon. So B prime from our fake point. Again, we leave X and Y in the same spot, so -8. And we have -4. Sorry, my handwriting's a little bad on this, guys. But now we're going to change direction for both. So our negative numbers now become positive. And we're going to graph from our fake origin point in a second, and you'll see that on the screen. And then again, our C, we keep the points in the same spot. Do we switch X and Y? No, we leave them in the same spot. And we're going to flip direction for both. So this -10 becomes positive, and 0 stays the same. So we're going to graph these new points from here, from our fake origin point. I will end up clearing my screen in a moment, and you'll see it better. I've already plugged these numbers into Desmos, but just to show you what to do, A prime will be here, because again, that's our fixed point. To find where B prime will be located, we're going to start here and count 8 to the right and up 4. So 1, 2, 3, 4, 5, 6, 7, 8, and up 4. Again, you'll see a much clearer screen in a moment because you're already doing this on your paper. Again, we have to use the fake points to find real answers. So we're starting here at our fake origin point, 0, 0, which is where A prime is. And we're going to go for our C prime, again, that states right 10 and 0. So we'll count right 10 positions. And again, we're going to stay there. So first, let me clear my screen and get back to the pointer I've learned from a couple of times here. So again, we counted from our fake origin point, we kept our X and Y in the same location, and we changed direction for both. Again, from our fake point, we had -10, 0. We kept them in the same position, and we changed direction for both. Again, at this step, you almost want to think of them as vectors. And then we go ahead and graph. So here is like what I mentioned before. Here is our brand new, on the Desmos, beautifully rotated 180 degrees about point A, triangle A prime, B prime, C prime. But in order to answer our question on our worksheet, it does say, hold up, because we used fake points to find real answers. There was that prep step in the beginning. There is a post step. So our A, pre-image A, B, C, our post, our A prime is in the same spot because again, it stayed in the same position. Our B prime is located not at that 8, 4 that we looked at before, but on the actual graph when we actually locate, and how many times can I say actually, friends, when we graphed it from our point 8, remember we counted 8 right, up 4 on the actual graph, because remember, origin is located here. Our final point is right 10, up 1. Also looking for our actual real answer, even though we used fake points to find real answers, C prime is located 12, -3. Again, we counted 10 to the right and 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0. But when we look at the graph as our last step, because the last step here is to read it off the full graph, our C prime is located right 12 and down 3. All right, there you go. That's how you rotate around a fixed point. Don't forget that those rules for rotation. Yes, no, yes, no. Am I pointing to the right? Flip direction for the right. Pointing down, flip direction for both. Pointing to the left, change direction on the left. And that's how easy it is to rotate. All right, we just got a few left to go.